Bismillahirrahmanirrahim. This is lecture number 25. Up to now we have discussed reflection and refraction of waves from half space, surface of half space, and from two joined half spaces, surface of two joined half spaces. Now we shall move on, and now we will discuss Rayleigh surface waves. Surface waves. What does a surface wave mean? As it from its name, surface wave, that it moves on the surface. Like you can have example of water wave, that if you throw a stone in the water, then you can see that disturbance will be produced on the surface of water, and that is water wave. Water wave is the example of surface wave that moves on the surface of water. Now, as this type of wave has been first time studied by Rayleigh, that is why it is also called Rayleigh surface wave. So, as I have written here, that the possibility of a wave traveling along the free surface, that moves along the free surface of an elastic half space, such that, no, this is another property of that wave, such that the disturbance is largely confined to the neighborhood of the boundary. It means that when we will move away from the boundary, then the displacement will decrease. Displacement of that wave will decrease if we will move away from the boundary. And due to this name Rayleigh, it is called Rayleigh surface wave. That Rayleigh has considered this type of wave first time, and it is called Rayleigh surface wave. Here I have written that the criteria for surface waves or Rayleigh wave is that the displacement decays exponentially with the distance from the free surface. Now we shall investigate here a two-dimensional Rayleigh wave, and we will suppose that it will propagate in the x1 direction. Now this is some geometry about this wave, that wave move like this along x1 direction, and here you can see that this is the form of an ellipse. As Rayleigh wave basically contains longitudinal and transverse both, so motion of the particle will be in the form of ellipse. That when it moves, when waves moves, then the particle which moves with this wave will be in their motion will be in the form of ellipse. Their motion will be elliptical. Here you can see that as this wave moving towards here, this side is supposed to be undisturbed. This is undisturbed region of this whole surface. It is moving, and when it moves, it disturbs the ground like a ellipse. That here you can see that particle will move in the form of ellipse. That it moves like this here, then they will move from left to right. This is the direction of the wave, that wave is moving from left to right. Particle will also move from here to there, but in the form of ellipse, like this, again like this, and they will reach on this side. Now, as we are seeing that displacement decreases when we move away from the surface, then our displacement should be in such form that they must satisfy this type of property. Here you can see that as we are supposing that we are in x1, x2, so u3 is identically 0. So we have two components of displacement, u1 and u2. u1 in this form and u2 is then from this form. A, b, they both are constant. This is b. This is the coefficient of x2, b. This is the coefficient of b of x2, minus, and this term e power minus bx2, e power minus bx2 is denoting that when we move away from the surface x2, then this will go to 0. When value of x2 increases, then this will go to 0. So as we have said in the above paragraph, that it decays, that displacement decays exponentially. So due to this term, our displacement u1 and u2 will decrease exponentially. And keep in mind that here this b should be positive, should have a positive real part. If it is imaginary, then it should have positive real part. Why it is positive real part? Because if it is negative, then by increasing x2, this term can't be 0, can't go to 0. So that is why our real part of this b should be positive, so to have the property of that Rayleigh wave. Now what does this tell? This says that as we are moving along the x1 direction, that as wave is propagating along x1 direction, so here will be x1 minus ct. C is the phase speed of the Rayleigh wave, and t is the velocity, time. When what is k? K is the wave number of that wave. Similarly, we have u2. These constants will be calculated, a and b. We will calculate these constants a and b, also b and c will be calculated. Now b and c will be calculated. No, here we will use displacement equations in which displacement components are involved. So as u is the variable in the displacement equation, so value of u must satisfy those equations. Then we will apply the boundary conditions and have value of c phase velocity, value of c phase velocity. And we are supposing that we have free stresses, so it means that we will have to calculate stress components there at x2 is equal to 0. Now this is the equation of motion for displacement, and you can see that this is for the isotropic material, that we are supposing that we have isotropic material in the half space. So that is why we have considered this type of equation that is particular for isotropic material. Equation number 1. This you can also see that this is a vector form of the equation. U is the vector, and you have 3 components: u1, u2, u3. So it means that this equation number 1 has 3 equations, 3 sub equations, 1, 2 and 3. But as we have u3 equals to 0, so we have basically 2 equations, u for u1 and u2. So we can write this equation 1 for u1 and u2 as 2 and 3. You can see that partial square, this is what is this? This del square is partial square partial x1 square plus partial square partial x2 square plus partial square partial x3 square. And for first component of this will be partial square u1 partial x1 square plus partial square u1 partial x2 square plus partial square u1 partial x3 square. That will be 0. Why? Because u1 and u2 are independent of x3, so no need to write that. This is lambda plus mu, and this is divergence of u. They are partial u1 partial x1 plus partial u1 partial x2 and plus partial u3 partial x3, and we have no u3, so it means that we have no third term here in this sum. So this is partial by partial x1. Now this is the first component from here. This is the first component from here, gradient of this scalar divergence of u. And on right side we have rho partial square u1 partial t square. So similarly we have second equation, and third is automatically certified 0 is equal to 0. Now we will use values of u1 and u2 given here, here, u1 and u2. Now we will use these two, u1 and u2, in equation 1, equation number 2 and equation number 2, equation number 3. Simply what we have to do, we have to calculate simple partial derivatives of u1 and u2 and replace those partial derivatives in equation number 1 and 2. We will have two equations. Simply two equations and two unknowns. From there we will calculate RB, small b. Now by using u1 and u2 from into equation 2 and 3, we have this equation number 4 and 5. Here we have used simply partial derivatives on u and u2, nothing else. You will have exponential in each term of this equation number 4 and equation number 5. So when we will take that exponential outside, so we can write not that exponential not equal to 0, and the remaining will be equation number 4 and remaining will be equation number 5. When you will put these u1 and u2 in equation number 3, you will have equation number 5. Now what we have to do, now what we do, you can see that we have c, phase velocity of Rayleigh wave. Now we convert these constants, these lamb's constant mu and lambda plus mu. You can see that from equation number 4 and 5 we have mu and lambda in the equation number 4 and 5. Now we will convert these lambda and mu in terms of longitudinal wave speed and transverse wave speed, so that we have CL, CT and C everywhere in the equation 4 and 5 instead of these constants lambda and mu. So we know that our CT is equal to this and CL is equal to this. You have these two expressions in your previous lectures. You can have these from there. So you can write this as, and also you can write this thing as lambda plus 2 mu equals to rho CL square. You can write the lambda plus 2 mu equals to rho CL square minus mu from here. So we have mu equals to rho CL, so CT square, and lambda plus mu equals to rho CL square minus rho CT square. So when you will use, instead of mu, rho CT square, and instead of this thing, you can see that rho here first term, rho in the second term, and rho in the right hand side term. So it will be cancelled out. What is rho? Rho is basically the density of the material, which we will use for the half space. So this will be cancelled out. After cancellation, no, we have used these in our equation number 4. Then we will be used in equation number 5. Now we have combined the coefficients of A here and B here. After a simple calculation, we have this b square ct square, one thing will be cancelled out from here, which is k square ct square, and a. This is equation number 4a. Now this is equation number 4a. This is the coefficient of a, this is the coefficient of b. Now from equation number 5, equation number which one? Equation number 5. Now from equation number 5, use mu and lambda plus mu in terms of CL and CT. We have this. Again combining A and coefficients of A and B, we have this. Now we have system of equations. This system contains 4A and 5A. Now we have two constants A and B. Now this is homogeneous system for A and B. And we know that homogeneous system always has a trivial solution. So we always look for a non-trivial solution of the homogeneous system if that exists. So for the existence of the non-trivial solution of this homogeneous system, we must have determinant of the coefficient matrix should be equal to 0. If determinant is not equal to 0, then we cannot have non-trivial solution of this system. So to have the non-trivial solution, we must have determinant equals to 0. And this is the determinant of the above system, 4a and 5a coefficient matrix system, determinant of the coefficient matrix. So this is equal to 0. Now here you can, we will simply rearrange the things like that. As when I have started, I was saying that we have to calculate B, C and the constants A and B. Now first we are going to calculate B, as I have said earlier. So what we will do here, we will simply separate the coefficients of B. Now you can see that we have only B square and B4 here in this equation. So we will separate the coefficients of B4 and B square and plus constant. So this would be a quadratic equation in B square. Not in B, it will be quadratic equation in B square. This is the constant. You can write this simply, open this square and simplify something here, like then you will have this and this. After division with the help of the CL and CT square, you have this type of thing. No, if you look carefully on this, then this is simple an equation like this: x square minus ab x. This expression, this left hand side not equation, this expression on the left hand side will be same as this expression, and we can write this equals to this: x minus a into x minus b. Multiply these two, we have this type of expression. So what we will do, we will identify what is our a here, what is our b here. So what is x? Now our x is b square, our a is this, b is this. You can see that a is this, k square, multiply k square inside, k square into 1 minus cl, c square plus b, k square into 1 minus cl square, c square, ct square, and ab, multiplication of ab, which is the constant term, ab, k4, and this which is here and here. You can have a equals to this, b is equal to this is up to you. So no need to remember this thing that you have to write a only in the form of cl. You can write a equals to this, b equals to this, nothing will happen. You will have the same result at the end. So what we can write, we can write this thing with the help of this as x minus a and x minus b. So this will be b1 and b2. We are not writing minus because we have supposed that b1 and b2 should be positive. B should be positive, so we are not writing minus here, plus. And for real, this should hold. Our c must be less than ct and ct must be less than cl. It obvious that ct is always less than cl. And c is less than ct and cl. In this case, your b1 and b2 will be real and positive. So as we have two things, b1 and b2 in the start. In the start, when we have u1 and u2, there is only one b. No, we have two b, b1 and b2. So we know we can write the general solution of the displacement in this form. Like you can see that b1, in the start we have a into e power minus bx2. Now we have b1 and b2, so we can write a1 e power minus b1x2 plus a2 e power minus b2x2. It will remain same. Then from u2, b1 and b2. Now you can see that in equation 4b and 5b there are four constants, a1, a2, ab1 and b2. But actually there are two constants. Why there are two? Because a1 and b1 are related with each other and a2 and b2 are related with each other. We will see that how they are related with each other and how, with the help of which equations we can find their relation. So with the help of 4a, you can write instead of b, b1, a1, b1, b1. Simplify this. This is from equation number, this is, you can write this thing from b1, from the value of b1 you can write this. So you will use b1. If you will write here b2, then this from them, but due to your b value of b1 here will be b1. So to avoid that thing, write from equation number 4 a as b1, a1, b1, b1. After simplification you have this b1, this capital B1. Now this is the relation between B1 and A1, that if you have A1, then you can have your capital B1 from here. Now from 5A you have B2 here. Now using these two in equation number 6 and 7, in equation 4B and 5B you have equation number 6 and 7. You can see that. Now you have two equations, 6 and 7, and two unknowns, A1 and A2 are there. So you have to calculate these A1 and A2. Now we will apply the boundary conditions. Now what are they? We have free boundaries. So stress components will be 0. So from there we will have two equations, and in two equations we will have two unknowns on A1 and N2. So by solving that, let's see what we have. By solving that, let's see what we will have. This will be discussed in next lecture, inshallah. That we will apply the boundary conditions and see what happens, that what we have from that. So thank you so much. Go through this. If you have any question, then you can ask. Then you can ask me at any time. Thank you so much. Allah Hafiz.